Hello, 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 and welcome to our next session led by the one and only Šimon Podhajský. Šimon is here today to tell us about small batch, artisanal data workflows and how we can craft them into our data work. And I'm really excited to have Šimon here today. I'm going to embarrass Šimon a little bit. Šimon has been in the DBT community for a while now, and he always comes in and with very thoughtful, very warm and engaging interactions. And we're just like really thrilled to have him out here today. And so I want to have everyone give a nice warm round of applause for Šimon, and then I will pass it off to him. And remember, comments, questions, anything, those will all go in the Slack channel, and then after the session, Šimon will be in there hanging out and answering the questions. And now, Šimon.
Hi, everyone. First of all, I want to thank Jason for the warm welcome and for his skill in pronouncing my name. It's uncanny. Today, I'm going to be talking about a subject that's near and dear to my heart, which is bringing the modern data stack to academic research, where it usually is nowhere to be found. A little bit about me. I've been doing neuroscience research for the past 6 or so years, with mostly overlap into cognitive science and psychology. Today I'm going to be talking mostly about the kinds of research that happen in the social sciences, which have two characteristics. One, a lot of researchers do them on their own laptops. They're a single machine endeavor, and typically reliant on the environment that is set up there. So that is a challenge in its own right. The second one is that it's mostly file-based, not database-based. And most of that data, though not all of it, is tabular. Hence the Excel icons. Now, there are other kinds of research and other kinds of data, of course. Those have to be approached differently, and I'm going to be talking about them. But this does fit a surprising amount of the social science research. One thing I want to say about this is that I joke that academia is just paved with CSV files. And that's not quite true. Some of them are TSV files, some of them are ePrime files. A lot of them are SAV files that come from random programs that are used only in academia and nowhere else. So those are the things that we contend with. Now, most academic research has this sort of a processing. It comes from something like RedCap or Qualtrics, which are specialized data acquisition and storage platforms, though it can come from other things as well. Some people will just record things from Google Forms. Some people will use specialized programs, but this is a good stand-in. They will run through arbitrary scripts, hopefully scripts, sometimes not even scripts, sometimes just processing in Excel spreadsheets and copying from one sheet to another and hoping that nothing broke in the meantime. And they will be taken by some specialized programs, R if you're lucky, MATLAB and SPSS and SAS if you're not. And then you get publishable results, maybe, if you're lucky. And sort of hope to God that nobody takes you up on your promise to share your data with them if it's being requested. And there are a couple of problems with this, and I'm going to talk about them. But the primary ones that are solved with DBT in particular and modern data stack in general are the following. One is documentation of the data and of the research. In the file system, there is no obvious way to connect the data to the explanation of the data or to the lineage of the data. right? And in the last couple of years, there have been some solutions that have addressed this. We have tried to standardize on some data dictionary formats, but mostly this does not really work. But it is a problem that's pretty solved in the database world, right? We have column descriptions. DBT gives you lineage. We've got all that. A secondary problem is computational reproducibility. And I'm going to show you an example later in the talk of how typically people share their data and their scripts. But typically, a lot of researchers just have to know which scripts to run on which data files, and magically how to get the results that have made their way into the papers. And experimental reproducibility, of course, referring to the description of what the data means, how the data was acquired, how it might be acquired again. Third, a lot of the data isn't really doubly tested. It's not really robust. And testing in general is not really applied to data very often in the academic context. And lastly, there is very little preparation for scaling the approach to more data, should it be necessary, or publishing the entire pipeline somewhere where other people might play with it and possibly critique it, right? So a lot of the results end up being siloed and only reproducible from a couple of papers, from a couple of figures in the paper. Now, you are at a DBT conference, so this should all ring a bell as to why DBT might be a good candidate for solving these problems, right? In DBT, the data transformation lives right next to the documentation. In DBT, you've got the DBT run, which tells you where to start and where to end. You've got data testing that's combined a lot of the time with the description. So you can assert things about the data right as you write about it. And of course, it's made to be deployed. So all of these problems are something that get us to our solution, which is documented, reproducible, robust, scalable statistical pipeline, running locally and deployable globally. So in the modern data stack, if we want to preserve the local running, we still have options, even though almost all the definitions of the modern data stack say that you've got to have the cloud in there. With DuckDB, we have sort of started getting into the areas of where you don't need it all that much. So the idea here would be that you still draw from the systems that you have or from the CSVs that you have, but you use Meltano to start creating the extraction, load, transformation pipeline and run it all in one bit. Save the transformations to DuckDB, then use Daxter or some other orchestrator to run the statistical analyses. For extra points, save the results in DuckDB as well. And then you can either save the DuckDB on Amazon S3, or you can deploy this in a pipeline on EC2, or you can just keep it on your computer, but let the future you have an easier job of running it in 2 years when you've forgotten how to do it. And hopefully you'll still end up with a publishable paper, which is sadly sometimes all that matters in academia. Now, this is a little bit of a moment where I sell to the audience that's not in the room, because I'm going to be selling the benefits of DBT, and most of you sitting here in this room already know that DBT is pretty great. So it is easy to document models, columns, and tests It is very clear which transformations depend on which others, and typically what software you need to run the transformations. SQL can do most anything that everyone else can do in the transformation layer, less so in the fancy statistical and machine learning layer, but that's what the rest of the pipeline is for. Snapshots can capture evolving data. If your project is a longitudinal project, if you're running analyses on continually evolving data, if you, for instance, like I have, are writing papers based on COVID longitudinal surveys of teenagers and or young adults, you want to be able to reproduce the analysis as it was with the data that you had back in April, even though it's September, and dbt snapshots can help you do that as the data comes in. dbt packages obviously help with some of the common transformation steps. It is easy to make the data tests that are orthogonal to the data processing pipeline, which is something that sometimes even the academics who do want to test their data struggle with, because if you have assertions in your analytic code, then it stops your analytic code and it sort of dilutes it. With dbt, it's easy to have tests that are just about the data and run and fail on their own accord. And finally, dbt and version control is a love story, as we all know. And version control is something that's very difficult to push in academia sometimes. So using a tool that makes it easy for your use case as well. Now, I'm making it sound like academia is behind the times, and it kind of is, but there's reasons why the modern data stack hasn't caught on yet. The main one, to me, is that if you remember the wall of Excel files, that should clue you in to the fact that there are relatively few databases going around. And DuckDB solves this a little bit. It makes it easy to move between files and databases. And once you've move your data to DuckDB, it is easy to also utilize a cloud database if you so desire. There are issues with privacy, private data, private health information, and those can keep you grounded to your local or on-premise database. But once you've started with a database, it becomes easier to continue with the database, even if you have to censor it in the process. A secondary consideration is that a lot of the sale value of dbt is that you can continue to model and transform data as it comes in. And with academic projects, that is relatively rare. A lot of the sort of small batch artisanal academic projects just collect data once, or maybe a couple times they iterate on pilot methods, and then like they write the paper and then never use the data again. There are some longitudinal studies that would benefit from this, but that's not the majority of the studies that we do. But this is not a key thing to dbt and the value of dbt. It's just something that is dbt is often used for. And lastly, SQL databases, dbt, they're not really often taught, and neither is learning how to build solid infrastructure that can reproduce your code in and out. Because a lot of the academics just care about getting the results out and getting the papers out. But in here, I would argue that it is not difficult to set up this infrastructure. And once you have it, it becomes easier to write more papers and write them faster. So that's my sales pitch. Now, for the example, I will be looking at a reproducibility study by professors from Stanford, Michael Frank and Stephen Holbar, reproducing a study by Dr. Monin about moral rebels, which is not really relevant. But it is shared on the Open Science Foundation's repository, which is an excellent thing. It's like GitHub for academics that some people use. And I don't mean to dunk on this. This is still pretty good within the context. But you can see that they've shared the Qualtrics basis. They've shared the pipeline R scripts, and they've shared the data files. And in this case, this is simple enough that we can sort of imagine that you probably downloaded the data first from Qualtrics. That's probably data original. Then you ran dataprep.r. That created dataprepped.csv, and then you ran analysis.r on top of that. It's not always this easy, but in this case, I took this as an example because I needed an easy one. Come on. Now, this, the modern data stack take on this study would be very simple. We would pick up Meltano to load the data into DuckDB, use the CSV tab to do that. We would use either Daxter or Meltano to start the dbt run. Turns out you can use both, which I did not realize back when I was planning this, to run the transformation and get the data ready for analysis, and possibly test them if you want to make sure before the analysis is done that the data passes whatever assumptions you have for it. Then you launch the follow-up statistical analyses with Daxter. Possibly if you have multiple scripts, as you often do in some more complicated studies, you would have a more complex structure of which scripts depend on which, whether they produce any in-between artifacts that you want to reuse in other scripts. You can either model this in Daxter, you can model this with specific packages for specific statistical software. R has a lot of pipelining packages now that are excellent. So that can make things easy for you. The particulars of the orchestration, I've chosen to work with Daxter, but there's a number of options. And for extra points, if you have results of the statistical analyses, you can save them in DuckDB and then either keep it for future reference or share it on S3 or any other storage with whatever security considerations you need for this, and make it easier for those follow-up graduate students who will try to reproduce your analysis to actually do that with the exact process that you have used. Now, this is a very simple example. To make everything fit on one screen, I just picked one variable. Again, the people in this room have probably seen a dbt source and model before. But on the left-hand side, you have the SQL model that just renames one column. On the right-hand side, you have the documentation that specifies where the data is coming from, what the model is doing, and what the columns mean, and what properties they should have. In this case, we just have the properties of them being not null and unique. But we could have any number of other kinds of tests. For instance, if you have a more complex set of incoming data, you might want to check that the transformation model, after being joined with other models, still has the same number of rows as the source model. You might check that there are some relationships between columns that are preserved. You might check that an attention check column always has the right value. If you have been meaning to take it out as part of the transformation, you can do any number of things that you can do with dbt. And then, of course, once dbt runs, this produces a fully annotated DuckDB database that you can then do pretty much anything with, right? Because databases are great for funneling data to any tool that you might want, be it R or Python or MATLAB, be it a business intelligence tool. I haven't personally met any academic who uses Tableau or Superset, but with Meltano, it's very easy to run Superset. If any of you have seen Jacob Matsson's tweet from earlier this week, I felt very, scooped, because that's exactly, his article is exactly what I'm trying to do here. You can just easily run whatever data exploration or data analysis you need on top of the data that DBT prepares. And then you can ship that, version control it, either on GitHub or the Open Science Framework, osf.io, or any other data and code repository that your funders require, or that is your favorite. And after that, when someone writes to you and requests your code and your data, you can just set up whatever security permissions you need on S3 or elsewhere to share that. So the reproducibility is assured. And when you come back to the data in 2 or 3 years, you also know where to start. You have a reusable system that hasn't necessarily required you to change things in an Excel spreadsheet on your own once and do it correctly. You've got the full benefit of the automatic reproducibility of running a Meltano run or Daxter run once and having the results that you want. This is where I could this is where I could expand on some of the more automatic ways of also integrating it directly into whatever manuscript you have with Quattro or R Markdown. That can also be something that Daxter orchestrates. But I think this is a good moment to end it, because this is what the promise of the modern data stack is. Everything else is commentary. Everything else is just something that you do that you've always been doing with the statistical software that you've been using. So with that, I thank you for your attention, and I'll be looking forward to any questions in the Slack. Thank you very much.